Hi everyone, this is Mrs. G8 and today we're going to be talking about radian measure. Before we get started with the lesson, I do have a quick warm-up for you guys. So this is from the last lesson. Please find one positive and one coterminal angle for each of the following. Pause the video and give this a try, and we'll check your answers in just a few seconds. Alright, go ahead and check your answers here. So just remember, we can find positive or negative coterminal angles by simply adding or subtracting a full rotation, which is 360 degrees. So here are just some potential answers. There's actually an infinite number of answers. Just be careful here with 720. You could add 360, but I would actually subtract 360 because it still gives you a positive answer, but it's just smaller. If you subtract 360 again, you get 0, which is technically neither positive nor negative. So you should just subtract 360 again to get your negative coterminal angle. So I want to remind you, in the last lesson, we briefly talked about the fact that angles can be measured with two different units. So degrees and radians. So we learned degrees in the last unit, but today we're going to talk about radians, which is actually probably what we're going to use even more, especially when you move on to pre-calculus. So here's the definition of what a radian is, or how it's derived. So for any central angle, which we can call theta, that intercepts an arc with a length of s, so you can see the length of this arc from here to here, they labeled s, with a radius of r. The radian measurement can simply be found by saying theta, the angle, is the arc length divided by the radius, so s over r. So this is the technical definition for what a radian is and kind of how it's found. Now, a full rotation around a circle has a measurement of 360 degrees. We know that from the last lesson. In radians, a full rotation, we call it 2 pi. So I want to remind you that pi is simply a Greek letter that we use. It stands for an irrational number. It's about 3.14. So if we actually did 2 times that, it's around 6.3 if you round. But again, we say that it's 2 pi. So pi is actually part of the number. So we'd say 2 pi radians. Now, one thing I want you to note is that there is actually no written unit for radians. So for degrees, right, we know that it's in degrees because of this little tiny circle up here. That's our unit. So, just like when we measure something, we would write like 25 inches, we would write IN, or if we have centimeters, we would write CM. For radians, there's actually no written unit. The pi is not the unit for radians. Pi is part of the number. So whenever we're working radians, you just have the number there. You don't actually write out radians. It's kind of implied if you don't see a unit that it's in radians. But just remember, a full circle is 2 pi. So that's going to be really important as we move forward with today's lesson. Okay, so we're going to see if we can fill out these commonly used angles. We talked about them. They're the 30s and the 45s and the 60s. We talked about those at the end of the last video. We're going to see if we're going to fill them out for radians. And so this is, we're going to work with what's called a unit circle. So a unit circle is a circle that has a radius of 1. So let's just imagine that all of these radii have an exact length of 1. Okay, but again, we're going to use logic to figure out those measurements in radians. So the positive x-axis is still our starting point, and this would be 0. So 0 radians. And remember, a full rotation is 2 pi. So this is also 2 pi radians. Okay, so let's start using logic. If a full rotation is 2 pi, half a rotation is going to simply be pi. So 180 degrees is pi radians. Okay, so far so good. Now if this is half a circle is pi, well, this is cutting that in half. So this 90-degree angle we'd actually call pi over 2. So it's half of pi. So this is 1 pi over 2, 2 pi over 2. If we add another half, this becomes 3 pi over 2. And then if we add another half, that becomes 4 pi over 2, which is 2 pi. So you can see that we're actually adding half pi to get our angles for our axes. Okay? Well, now let's talk about, well, what if we do these 60-degree angles? So what if we do here and here? Okay, so imagine we're splitting the top of our circle into 3 parts, right? This is 3 equal parts. 1, 2, 3. So from here to here is 1/3 of this length. So we're going to add pi over 3, third of pi. So this is pi over 3. So 1 pi over 3. This is 2 pi over 3. This would give us 3 pi over 3, which simplifies to just pi. And then if we continue our pattern, here's the next third. So again, this was 3 pi over 3. So that means that this is 4 pi over 3. This brings us to 5 pi over 3. And then this brings us to 6 pi over 3, which simplifies to 2 pi. So you can see we're adding 1 pi over 3 to get those 60-degree angles. Okay? Now let's do those 45-degree angles. So it's going to be here. So if I added 45, right, it brings us here, here, which we already have, but that's okay. So we're counting by fourths now, right? So there's 4 slices in this half circle. So again, if there's 4 slices, that's going to be pi over 4. We're splitting it into 4 parts. So that brings us to this first one, which is pi over 4, 1 pi over 4. This is 2 pi over 4, which was simplified. That brings us to 3 pi over 4. And then 4 pi over 4, which is simplified. Let's continue our pattern. That means this must be 5 pi over 4. This is 6 pi over 4, which is simplified. That means this is 7 pi over 4, and then 8 pi over 4, which is simplified to 2 pi. So that's our 45-degree angles, and notice we're just splitting up this half circle into 4 parts. And now let's do our last one. How about that? Those 30-degree angles. So that would be 30, 60, 90, 120, 150, 180. So you can see that this is actually split into 6 parts. 1, 2, 3, 4, 5, 6. So if we're going to do half a circle in 6 parts, it's pi over 6. So this would be 1 pi over 6, and then we have 2 pi over 6, 3 pi over 6, 4 pi over 6, and then this gives us 5 pi over 6, and then 6 pi over 6, so it's simplified. Let's continue. This gives us 7 pi over 6, and then we have 8 pi over 6, 9 pi over 6, 10 pi over 6, and then 11 pi over 6 here. And then that brings us back to 12 pi over 6, which is simplified. So you can see that just by using logic and fractions, if we know that a full rotation is 2 pi, we can break down our commonly used angles just into fractions of pi. So you'll notice that the angles that were the 30-degree angles here are all over 6. So we have 1 pi over 6, 5 pi over 6, so remember we're just 1 slice short, 7 pi over 6, so we have a full pi plus an extra slice, and then 11 pi over 6, so we're 1 slice short of 2 pi. Our 45-degree angles are all over 4. 1 pi over 4, 3 pi over 4, 5 pi over 4, 7 pi over 4. And our 60-degree angles are all over 3. Pi over 3, 2 pi over 3, 4 pi over 3, 5 pi over 3. So notice also the over 6s are closest to our x-axis, here and here. The pi over 4s are always in the middle, and the pi over 3s are farthest from our x-axis. So again, these are the commonly used angles, except now they are in radian measurement rather than degrees. So now that we know how to break down a circle into between degrees and radians, we're going to now talk about how we can convert from one to the other. So we're going to convert using a really common conversion factor that 180 degrees is equal to pi radians. And we're going to use dimensional analysis to convert. So if you've never used dimensional analysis, I highly recommend it for any type of conversion. It's really, really useful. So we kind of set it up like this. So here we're starting with 120 degrees. Well, think of this as a fraction. If I have degrees on the top, I could cancel out that unit of degrees by putting a measurement for degrees on the bottom. So I'm going to look at my conversion factor, and I'm going to put 180 degrees on the bottom. But I can't just divide by 180. I have to put something that is equal to 180 degrees right on top of it, because that essentially gives us 1. So I'll put pi radians on top. So this actually cancels out our units. So degrees are now canceled out, and what I'm left with is radians, because this is actually in radians. I'll write RADS. You don't have to write that to show that you're in radians, but I'll just do it for the examples here. So then, for dimensional analysis, we multiply across the top and then across the bottom, and that will be our answer. So 120 times pi divided by 180. And then here we just simplify. So you can see that the zeros cancel out, and then we could actually divide both by 6. So this simplifies to 2 pi over 3. So there you go. All right, let's try negative 225 degrees. So again, if I have degrees on the top, I'm going to put my measurement for degrees on the bottom, so they cancel out. But I have to put something equivalent right on top. 180 degrees is equal to pi radians. And then I multiply across the top, so negative 225 pi over 180. And then we're just going to simplify this fraction. So I can divide them both by 45 degrees, and we get negative 5 pi over 4. And that's our measurement in radians. And again, we don't need to write RADS. If you don't see a unit, it's implied that it's in radians. Okay, so now we're going to do the opposite. Here we have pi over 6, and we know that this is in radians. So I'll put the unit on top. So like this. So technically our unit is in the numerator right now. So to cancel it out, we would like to have radians also in the denominator. So this time I'm going to put pi radians in the denominator, like this. But again, I can't just do that. I need to put something that it's equal to on top. So 180 degrees will go on top. And so you can see our units actually cancels out. So we're no longer in radians, and now we're in degrees. So we're going to multiply across the top and the bottom. So we get 180 pi over 6 pi, and we are in degrees. And then from here, we're simply going to simplify. So the pi's cancel out, and then 180 divided by 6 is 30. So this gives us 30 degrees. All right, and let's do this last one. So we have 7 pi over 4 radians. Again, since my units for radians is in the numerator, I'd like radians to be in the denominator, so it cancels out. So I'll put pi radians, and then I'll put 180 degrees on top. Remember, if you have something divided by itself, since they're equivalent, this is essentially just multiplying by 1. So radians, again, is going to cancel out, and I'm left with just being in degrees. So we can multiply across the top. So this gives us 1,260 pi over 4 pi degrees, and then we just simplify. So 1,260 divided by 4 is 315 degrees, and the pi's cancel out. So again, as long as you know your conversion factor, that 180 degrees is equal to pi radians, you can always convert from one to the other whenever you want. Just remember, when you're setting up the dimensional analysis, it's just like any other fraction. If something cancels out if you see it in the numerator and the denominator. All right, so now we're going to do some more practice of drawing our angles. So these are all in degrees, and then we're going to convert them to radians. So let's start with 210 degrees. So 210 degrees is going to fall in quadrant 3 because it's between 180 and 270. So here's 210 degrees. And then let's convert it. So we have 210 degrees. I'll put 180 degrees and then pi radians. And this gives us, so again, our degrees will cancel out, leaving us in radians. So we have 210 pi over 180, which gives us 7 pi over 6. So that's our radian measurement. All right, now let's do 270. So remember 270, sorry, here's 210. 270 is down here. This is one of our quadrant angles, so it's from here to here. Let's do our conversion, 270 degrees. And then here's our conversion ratio. Again, if you multiply across the top and you simplify, we get 3 pi over 2. All right, our next one is negative 45 degrees. So remember, negative angles move in that clockwise direction like this. So there's negative 45 degrees. Let's convert that to our radians. So 180 degrees goes on the bottom, pi radians goes on the top. And this would give us, if we simplify, negative pi over 4. All right, so how about at this time, why don't you pause the video and see if you could try these 3 on your own, and then in a few seconds unpause and you can check your answers. All right, go ahead and check your work. So negative 135 falls down here in quadrant 3. Here's my conversion, and it becomes negative 3 pi over 4. 150 degrees falls in quadrant 2. Here's my conversion, giving us 5 pi over 6 radians. And negative 300 degrees falls here in quadrant 1. Remember, moving in that clockwise direction. And our conversion gives us negative 5 pi over 3. Okay, so now we're going to do the opposite. We're going to draw the following angles in radians, and then we're going to convert them to degrees. So 3 pi over 2, so remember, if we're counting by half pi's, we have 1 pi over 2, 2 pi over 2, 3 pi over 2. So it's actually a quadrant angle, so right here, and that's 3 pi over 2. And let's convert that from radians, which is what we're in now, to degrees. So we put radians on the bottom and degrees on the top. And then if you multiply across and you simplify, that gives us 270 degrees. Okay, next we have negative 5 pi. So here, this one, negative 5 pi, it would be nice to have maybe a coterminal angle for us to work with. That's a little bit easier to plot. So just like finding coterminal angles in degrees, we can find them in radians by simply adding or subtracting a full rotation. So in this case, a full rotation, instead of adding 360 degrees, we're going to add 2 pi. So again, we're just finding a coterminal angle that's easier for us to work with. So let's add 2 pi, and that still is negative 3 pi. So if we add 2 pi again, that gives us negative pi radians. So this is something we can work with. We know that pi is just half a circle, and it's in the negative direction, so it's here. And when we're drawing it, so imagine here's negative 2 pi, negative 4 pi, and then we have negative 5 pi. So it has rotated around twice, plus that half a circle. So let's convert this to degrees. So we have negative 5 pi radians. We'll put radians on the bottom and 180 degrees on the top. And then when we multiply and simplify, like the pi's cancel out, we get negative 900 degrees. Okay, let's look at the next one, 3 pi over 4. So remember, we're counting by a quarter of a pi. So here's 1 pi over 4, 2 pi over 4, and then 3 pi over 4 is right in the middle of quadrant 2, right here. So we have 3 pi over 4 radians. Put radians on the bottom so they cancel out. 180 degrees on the top. And if we multiply and simplify, this gives us 135 degrees. All right, so at this time, why don't you go ahead and pause the video and give these 3 a try on your own, and then in a few moments you can unpause the video and check your answers. All right, so go ahead and check here. First, 8 pi over 3 is a pretty large angle, so we can find a smaller coterminal angle to make it easier to figure out where it is. So we can do that by simply subtracting 2 pi. Now if we have 8 pi over 3 and we want to subtract 2 pi, it's a little easier to write 2 pi as 6 pi over 3, and it gives us 2 pi over 3, so that we know that it falls in quadrant 2. Or we could count by thirds. Here's 1 pi over 3, 2 pi over 3, 3 pi over 3, 4, 5, 6, 7, 8. So it falls in quadrant 2, and it's a full rotation plus some. Here's my conversion, and this does convert to 480 degrees. So negative 7 pi over 6. So again, we know that this is negative 6 pi over 6, plus that extra slice gives us negative 7 pi over 6. Here's my conversion to negative 210 degrees. And then we know 2 pi is a full rotation, so like this. And maybe you can just say, oh, we know 2 pi is equal to 360 degrees, but if you'd like, here's the conversion ratio as well. So some people, it's much easier for them to convert to degrees first and then graph. However, I would like you to start trying to become familiar with that radian measurement, because again, this is what we'll be using more commonly with trigonometry, and especially in pre-calc, we really use radians a lot more often than degrees. All right, so that's all for today's lesson. Thank you guys so much for watching.